In this question, we need to drag the tiles on the right-hand side and move them into the chart to identify the characteristics of the function y is equal to 2, all multiplied by x minus 3 squared minus 2. First of all, we know that this is an expansion because the value for a is greater than 1. So we can drag expansion into place. The direction of opening is simple to determine because the leading coefficient is positive, so we know that this is opening upward. The vertex is also easy to determine because notice that this function is in vertex form. The vertex would be at 3 and negative 2. The pattern of squares. Moving right, 2 from the vertex. Recall that the regular step pattern goes over 1 unit, up 1 unit, over 2 units, up 4 units. That's for the function y equals x squared. Because this has been expanded by a factor of 2, instead of going over 2 up 4, we would go over 2 and up 8 units. Next, the domain. The domain for any quadratic is always x is all real numbers. The range. Notice that our vertex is at 3 and negative 2, and it's opening upward, so the minimum point would be at negative 2, so we know that y must be greater than or equal to negative 2. Taking a look at our vertex at 3, negative 2, we can determine the axis of symmetry. The axis of symmetry is always x is equal to whatever the x-coordinate is, so we will have x equals 3. The number of x-intercepts. Because our vertex has gone over 3 and then down 2 units, and it's opening upwards, we know that it's going to have to cross the x-axis twice, so therefore there must be 2 x-intercepts. Finally, our y-intercept. We know something about the y-intercept. We know that the y-intercept has an x value of 0 because obviously the y-intercept is on the y-axis. So we can substitute 0 into our equation to determine the y-intercept. Let's do that. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times 2 is 18. And finally, 18 minus 2 is 16. Let's check our solutions. And we are correct.